Hello, I'm Firyuza Yanchilina and you are watching Bold Science with Firyuza. Today we are approaching the most subtle and most treacherous criterion of a scientific hypothesis, one that is very often misunderstood. We discussed the second criterion, predictive power, in the previous video. You'll find the link in the top right corner of the screen. And now the third one, the most philosophical, the most deceptive, a criterion that seems simple but in reality shatters our usual ideas of what knowledge really is. Let's begin. Criterion number 3. Consistency. A scientific hypothesis must not contradict experimental facts and must not break established knowledge. But here lies a trap. Sometimes so-called accepted knowledge turns out to be wrong. This has happened many times. For a long time, heat was explained by the existence of a special heat fluid called caloric. This theory successfully described many processes and was considered rigorous physics. However, experiments involving friction showed that heat is a form of motion, not a substance. Caloric disappeared, despite being fully consistent with the knowledge of its time. Quantum physics shattered the idea of particles and waves as opposite mutually exclusive entities. Edwin Hubble's observations destroyed the notion of a static, stationary universe. Before that, cosmology was based on the assumption that the universe is unchanging in time. And this assumption was treated not as a hypothesis but as an established fact. Even Albert Einstein, when formulating the equation of general relativity, deliberately introduced the cosmological constant in order to obtain a stationary universe. Only after the discovery of cosmic expansion did it become clear that the immutability of the universe was not an experimental fact, but an incorrect theoretical interpretation caused by a lack of knowledge. So a hypothesis must not conflict with facts, but it has every right to challenge old interpretations if experiments are on its side. Otherwise, we would be forever trapped in past centuries. You would be surprised how many so-called facts in modern science fail even the mildest scrutiny and upon careful examination turn out not to be facts at all but persistent misconceptions. Many of them originated as working hypotheses, approximate interpretations, or outright errors. Over time, they were canonized, turned into dogmas, and stopped being questioned. They are no longer tested, they are cited. That is why innovation in science should begin not with building new theories, but with revisiting what is considered to be factual. Now let's return to the main question. Why are so many ideas today called scientific hypotheses, even though they satisfy none of the 3 criteria? Because often no one actually checks whether these ideas meet the criteria of a hypothesis. They accept it by inertia. A mathematical model looks impressive, and that alone turns out to be enough to label it a hypothesis. Within the scientific community, a belief has taken root that if a theory is popular or fashionable, it is automatically scientific. As a result, such ideas continue to be called hypotheses even when they are not testable or predict nothing at all. Examples of such hypotheses, which are essentially pseudo-hypotheses, I will analyze in my upcoming videos. So a genuine hypothesis must be bold, honest, and mortal. It must live under the constant risk of being refuted. Any hypothesis must satisfy 3 strict criteria, without which it has no right to be called scientific. First, falsifiability. A hypothesis must be confirmable or refutable by experiment. Second, Predictive power. A hypothesis must predict new phenomena that can be detected already now. Third, consistency. A hypothesis must not contradict repeatedly verified experimental data. Thank you for being with me on the channel Bold Science with Firyuza. If physics grounded in reality and experiments resonates with you, stay. We have many serious and fascinating topics ahead. Subscribe, like, and see you in the next videos.